Assalamualaikum and a very good good morning. For today, Madam akan explain lah the other experiments. Okay, so I will start with flow over years. So all the materials here you can refer to e-learning. So if you got any problem, then ask me. Okay. We have the experiment flow over years. The course outcome is to demonstrate the principle of hydraulics and to develop a proficiency in the use of laboratory experiments. We wanted to see whether students can observe the characteristic of flow over a rectangular and a triangular V-notch. So there are two sub-objectives for this experiment. First one is to determine the coefficient discharge of rectangular notch. Second is to determine the coefficient discharge of triangular or V-notch. So basically, student kena tahulah macam mana nak kira coefficients values. Okay, in this experiment, you have to know about this Bernoulli equations. Okay, so this Bernoulli equation you have seen in previous subject. So Bernoulli equations related to conservation of energy to a simplified flow model of a rectangular notch view. Which can see by this equation. Q means discharge, CD is your coefficient of discharge, L is breadth of notch, H is the head above bottom of notch. Okay, and then we have another similar equations that can be simplified from the first equations, which is here. There is some trigo function in the second equations. We have a Q symbol for discharge, CD coefficient of discharge, theta over 2 is half of the enclosed angle of the V, H is the head above button of notch. Okay, so to do the setup, make sure, okay, as you can see in the figure 1 show your rectangular and triangular notch. So in this figure, you can see that a hydraulic bench, rectangular notch, triangular notch, measuring scale, and the stopwatch. So these are important items that you must have for this experiment. So what is the procedure? First one, measure the notch dimension, assemble the equipment, and then check that the support at the half, and then open the water supply, measure the H and the thumb in allocating tank or hydraulic bench for a constant volume, and then repeat steps, 2 steps before this, which is step number 4 and 5, and then record the data at least for 7 sets. Okay, so in your data collections and presentations, make sure your raw data is presented in tabulate or in table. Okay, there is some calculation that you should compute based on your Bernoulli equation before this, that the one that I explained before, and then show your graph to see the relationship between your variables. Okay, for example, your Q and H to the power 3 over 2, and then Q or another H to the power 5 over 2, and then log Q and log H. Okay, so you can use graph paper, or you can use online graph paper to do to show the relationship. Okay, make sure you know how to compute the average value of the coefficients of discharge, and then in the presentations suggest a functional relationship between discharge coefficients and other parameter or variables. Okay, also show the comparison between the experimental and the theoretical value, okay, in terms of percentage of relative error. And then provide some critical assessment or discussion. Okay, and then whatever you have before this, you need to include the summary and end by the conclusions. Okay, last one, provide some suggestions or improvement to as the last part, so that we can get better results. Okay. Okay, so I will play video. Okay, for this experiment as shown here.
Jump offline. bersama dan jalinkan hubungan bermakna raya ini untuk menangi hadiah sehingga RM100,000 bersama Pepsi. Imbas kod QR untuk sertai sekarang.
In open channel hydraulics, weirs are commonly used to either regulate or measure the volumetric flow rates. They are of particular use in large-scale situations such as irrigation schemes, canals, and rivers. For small-scale applications, weirs are often referred to as notches and invariably are sharp-edged and manufactured from thin plate material. The flow pattern over a notch or weir is complex, and there is no analytical solution to the relationship between discharge and head, so that a semi-empirical approach has to be used. The objectives of this lab are to determine the characteristics of open channel flow over a rectangular and a triangular notch weirs, and to determine the values of discharge coefficient for both notches.
The weir flow apparatus has several elements, including a steering baffle, an inlet nozzle combined to promote smooth flow conditions in the channel, a vernier hook, and point gauge, all mounted on an instrument carrier. These instruments measure the depth of flow above the base of the notch. The weir notches are mounted in the carrier at the outlet end of the flow channel. To connect the delivery nozzle, the quick release connector is unscrewed from the bed of the channel and the nozzle screwed into place. The stowing baffle slides into the slots in the wall of the channel. These slots are polarized to ensure correct orientation of the baffle. The instrument carrier is located on the side channels of the molded top. The carrier may be moved along the channel to the required measurement position. The gauge is provided with a coarse adjustment locking screw and a fine adjustment nut. The vernier is located to the mast by the screw and is used in conjunction with the scale. The lock and point are clamped to the base of the mast by means of thumb screw.
Mount the V-notch weir plate into the flow channel. Turn on the pump and slightly adjust the flow control to fill the channel upstream of the weir with water. Turn off the pump when the water starts to flow over the weir. Wait 5 minutes to allow the water to settle. In order to measure the datum height with the height gauge of the base of the notch, H0, put the instrument carrier in this position. Then carefully lower the gauge until the point is just above the notch base and lock the coarse adjustment screw. Then, using the fine adjustment, adjust the gauge until the point just touches the notch bottom and take a reading. Be careful not to damage the gauge. The surface of the water as it approaches the weir will fall. This is particularly noticeable at high rates of discharge caused by high heads. To obtain an accurate measure of the undisturbed water level above the crest of the weir, it is necessary to place the head measuring gauge of a distance of at least 3 times the head. Adjust the point gauge to read 5 mm greater than the previous reading. Record the reading as H. Turn on the pump and slightly adjust the flow control until the water level coincides with the point gauge. Check that the level has stabilized before taking readings. Measure the flow rate using the volumetric tank. Observe the shape of the nap and take a picture of it. Increase the flow by opening the bench regulating valve to set up heads above the datum level in steps of 5 mm until the bench regulating valve is fully open. At each condition, measure the flow rate and observe the shape of the nap. To obtain a sufficiently accurate result, collect around 25 liters of water each time, or collect the water for at least 120 seconds. After the last measurement, close the regulating valve, stop the pump, and then replace the weir with the next weir to be tested. Repeat the procedure steps using the rectangular notch plate, but increase the point gauge by 10 mm increments instead of 5 mm.
Be sure to clean up your station and any water that may have spilled. Following the lab manual, complete the results table and put together your lab report. If you have any questions, consult your teaching assistant or professor.
Okay, so kalau rakaman video tadi tak berapa jelas, so you can refer you can refer to e-learning lah untuk tengok balik for this flow over wires. So Madam akan sambung dengan regimes flow of fixed bed. Okay, next experiment. So this is actually second part kan for the subject. So last week is one of the subfield kan. So for today is the second subfield for this lab. So regimes flow of fixed bed. The course outcome is your students should know how to demonstrate the principle of hydraulics and to develop a proficiency in the use of laboratory equipments. So the main objective is students should know to demonstrate visually the different regimes of open channel flow over a fixed bed. So this is only one objective, which is to analyze the occurrence of hydraulic jumps and their characteristic. Okay. The theory for this experiment basically lies on you punya concept of water flow. Okay, so this one Madam tak ada explain lah, because actually this is not in my field lah. Okay, so I believe that most of you already have this background for this, that related lah about this water flow and the fluid. So I will just directly show you the figure 1 here for the experimental setup. Okay, these are some of the basic terms that you should know lah for the setup. Fill the catch tank with clean water up the full mark, and then this is an optional equipment. So you can have the hook and the point gauge will be required for taking flow depth measurements. Okay, this is additional equipments. So here, if you want to do this experiment, just double check with the technicians whether the items are in the laboratory or not. Okay, so as usual, similar to previous experiment, all data should be recorded. Okay, so you have to show your data in the report, and then plot the graph, explains what is the relationship and so on. Okay. And then don't forget to include interpretations of the result which is come from the previous step, and then include or end by you punya recommendations to improve so that we can get better results. Okay, so for this experiment we have this video, so I will play now.
This lab exercise is to explore the hydraulic jump phenomenon. The objective is to learn what the hydraulic jump is and be able to properly create and measure a jump. Before we start the lab exercise, we must first learn a few definitions. The first important definition is critical depth. The critical depth represents the depth representing the minimum energy. Critical depth is dependent only on the flow rate and the geometry of the channel, as shown in the equation. Using the critical depth, we can classify the flow. The first classification is supercritical flow. The flow regime is supercritical when the flow depth is less than the critical depth for the given flow rate and channel geometry. Supercritical flow is generally associated with steeper slopes and mostly occurs in man-made channels. Some examples of supercritical flow are flow in street gutters, flow down a spillway, or flow in steep concrete channels. The second classification of flow is subcritical flow. The flow regime is subcritical when the flow depth is greater than the critical depth for the given flow rate and channel geometry. Subcritical flow is the most common type of flow and is a result of smaller channel slopes. Most natural channels have subcritical flow. With these two flow regimes now defined, we can define the hydraulic jump. A hydraulic jump occurs when a zone of supercritical flow discharges into a zone of subcritical flow, causing the depth of water to cross critical depth. The transition between the two flow regimes is associated with a large amount of energy dissipation. Common locations of hydraulic jumps are spillways, where the spillway discharges into the natural channel. It is of interest in engineering to know the ratio of flow depth across the hydraulic jump. This ratio can be computed by momentum conservation across the jump, as shown in the equation. We are now ready to go into the laboratory and create hydraulic jumps using a hydraulic flume. Protective clothing is a good idea, but not required for this exercise. Before we start the flume, the hoses must be checked for loose connections to prevent leakage. You can now start the pump and set the flow rate. The flow rate may be roughly adjusted to the desired flow rate by using the flow rate gauge below the end of the flume. For an accurate reading of the flow rate, use the hydraulic bench and stopwatch to read the volumetric change of water over a defined time interval. We can now set the slope on the flume to create the desired normal flow depth. Since we know the flow rate, we can calculate the critical depth for this flow rate, given a channel width of 76 millimeters. To help us create the hydraulic jump, we can mark critical depth on the side of the flume and use it as a reference point for supercritical and subcritical flow. In this case, we see that the flow of water in the flume is at or near critical depth. Take a moment now and think of ways the hydraulic jump could be created in this condition. Since the flow is near critical depth, we can use the stop logs at the end of the flume to create subcritical flow. Now that we have subcritical flow, we need to force supercritical flow upstream. This is done by inserting a sluice gate and setting it to the desired level. the sluice gate will back water up behind it. Check to make sure the water level doesn't get too high and start leaking. We can now verify the height of the jump by first taking a measurement of the upstream depth or the depth in the supercritical section. Using this depth and the flow rate, the depth downstream of the jump is calculated. This can then be verified with measurement. We are going to increase the slope. Take a moment and decide whether the critical depth line should be raised, stay the same, or be lowered. You're right, the critical depth does not change since it is only dependent on the flow rate and geometry, and neither was changed. We can see that increasing the flume slope has decreased the normal flow depth, such that we have supercritical flow. Since we already have supercritical flow, all that we need to do in this case is cause subcritical flow downstream. This is done by inserting stop logs at the outlet.
Okay.
Monza.com makes GANs great.
Okay, so tu tadi rakaman berkenaan dengan berkaitan dengan hydraulic jump. Okay, so untuk eksperimen berkaitan dengan hydraulics ni as usual lah untuk you punya bahagian kena submit you punya raw data dalam this assignment table for result and data analysis. Okay, so this submission untuk bahagian ni saja. Okay, bahagian eksperimen ni saja. So nanti saya akan update lah for the due date lah for this experiment bila nak submit. Tapi untuk kelas minggu lepas yang saya dah explain, okay, make sure eksperimen 1, 2, 3, okay, daripada turbidity sampailah chlorine test ni perlu submit sebelum 3 hari bulan 5. Okay, so tu saja. So kalau ada apa-apa soalan you boleh tanya melalui WhatsApp. Okay, thank you.